Hi, class. So this video is to help you find the average rate of change when you're given a function. So last video was when we were given a graph, how do we find the average rate of change? This one is if you're given a function only. So the idea is going to be really similar. Let me show you kind of what we saw last time. Before we started out by finding 2 points that both located with the endpoints of this interval. And so that's exactly what we're going to do in this problem. Although we don't have the graph, but we are going to have the x value, and we can find the y value that corresponds to that x value by plugging it into the function. Because we are focused on finding these 2 points, and as soon as we do that, then we can use the slope formula and find our answer. So how do we get these 2 points? We were able to read them off the graph when we were given a graph. This time we are given the x value, and we can just plug that x value into the formula to get the given y value for that x value, and then we'll get the 2 points that way, and then we'll be ready to use our slope formula. So what we're going to do is we're going to plug the first x value into the formula and figure out what the corresponding y value for that it would be. Okay, so it says find the average rate of change for this function g of x equals 4x cubed plus 1. From x equals -3 to x equals +3. So here are the endpoints that they're describing an interval, and here are the endpoints of that interval. So like we did before, we're going to find a point at the beginning of that interval. So I'm plugging in -3 into our function. So I'm going to write it all above. Whenever I plug something in, I like to rewrite the whole function right above it, so that I'm not looking back and forth with my eyes unless I can make mistakes. Okay, so I'm trying to find g of -3. What? So -3 cubed would be negative. It's important for us to expand that out and remember what that means. So it's -3 times -3 times -3, and the negative is part of the base of that. Notice how when I substitute something in, I put it in parentheses to make sure that was, and when I did that, I really emphasized that the -3 is a part of that base. So -3 times -3 is going to be +9 times by a negative is going to be negative again. So -27 times by 4. So let me grab my calculator really fast. Well, that's going to be 120 minus 12, which is 108, right? Does that make sense? Let me just double check it. 27 times by 4, 108. Okay. And it's -108. And we can just double check our negative sign there, because when we have an expression and being all these numbers being multiplied, we can count the number of negative signs. So 1, 2, 3 negative signs, and we know that the final answer is going to be negative as well. So we do have that correct. And then we have to make sure when we add these integers, they are on different teams, kind of. So the one positive is going to cancel out with no negative, and I'm going to end up with -107. So that is telling me that when I plugged in -3, I had a value of -107 with the corresponding y value. Remember, whatever is equal g of x, we can kind of all it is new replacement material, new replacement notation for just the y variable. So I'm talking about the y variable, but it's just what or sometimes it's called the function value at that value, or the corresponding, the height at that, of the graph when x equals 3, right? So when I say y variable, I just it's the same as the function value at that point. Okay, now we need to know what so I found 1 point. So right, like let's look at that at the graph. Remember the problem where I was given the graph and asked to find the average rate of change. Well, now I have found my first point. Now I need to find my second point. To find that second point, I need to, just like I needed to trace that second x value up, now I need to, instead of doing that, I'm going to be taking that second x value and plugging it in to find that second point. So g of x 4x cubed plus 1. So plugging in 3. So this is going to still be 27 because 3 times 3. And this is where a lot of students make mistakes are with these exponents. They'll do 3 times, they like to do times because they're doing it so fast in their mind. And that's why you need, sometimes when you're doing math, you have to just take a deep breath and you have to go slower. You can't like be doing math and be like, I only have 30 minutes to get this done and I really need to do this and that. And so, you can't be rushed with math. So if you're being rushed, you'd probably say, oh, 3 to the 3rd power, that's 9, because they multiply instead of actually expand out. So I like, a lot of times I expand it out so that I don't forget and do it incorrectly. This time it's positive 3 expanded out. So that's 27 times 4, which will be positive 108, plus 1, which will be 109. So the function value at 3, or the y value at 3 is going to be 109. So 3, 109. So now we have our 2 points. And we just have to find the slope between those 2 points to find the average rate of change. So we use the slope formula, that is y2 minus y1 over x2 minus x1. And then I'm going to call this my point 2, and this my point 1. And like I said, it doesn't matter which one I chose to 1 and which one I chose to 2. It's going to work out. You can try it yourself if you'd like to. 109 minus a negative 107 all over 3, which is x2 minus a negative 3. So this traffic jam nebula is going to end up being positive. So I'm going to get 216 over 6. And then we are going to be able to reduce that because we can see that they're both divisible by m. They're both divided by 2 at their minimum. So that's going to be 108 over 3. And then actually 3 goes into 108. I know because I can add the digits of that number, and then I can add the digits, and then so I know that and the digits are divisible by 3, so I know the whole number is divisible by 3. So let's quickly figure out what this is equal to, and it's 36. So our final answer here is 36, and there we go. And we can double check it. 36. All right. Please let me know if you have any questions, and have a great day. Bye.